Hi, I'm here to talk about NephEx, which is a nephelometer instrument our lab is designing in order to probe particles in planetary atmospheres. So the basic working of a nephelometer is here in this diagram. It consists of a laser which emits from the instrument and scatters in all directions from a cloud or from other atmospheric particles, and then reflects reflects back to a sensor in the instrument. The amount of backscattered light determines if it is passing through an area of atmospheric particles, and the intensity of that light tells us the size and concentration of those particles. The choice of wavelength for this is important. We want we want scattering to occur in the me scattering range. That's when we'll get the strongest signal. So we know, for example, the clouds on the clouds on Saturn or Venus should have particle sizes in the like 10 micron to 0.1 micron range. So right in here. So we chose a 785 and a 1550 nanometer laser, these two lines here, to get the maximum excitation. Anywhere in that near infrared range would have worked, but it's real easy to procure a laser in those wavelengths, and having a commercially available laser makes everything easier. The development stage instrument you can see right here. The brains of the thing is here, which is a BeagleBone Black, and it takes data and controls the lasers. The two lasers are right here, oriented now so they're shooting away from the page, and they're all mounted on just basic optical stages that you can buy from someplace like Edmund Optics. Assembled, the instrument is in this inset, and it's sitting now so that the lasers are pointing straight up in the air, and any reflection and backscatter would happen and come down to a sensor board that's sitting right there in that top enclosure. The optical stages are great because it makes a development stage instrument really easy to use, but you can kind of see it takes up at least half the space and half the mass of the instrument. So for a space-ready instrument, we'd build something custom and cut the volume in half. The photodiodes are right there mounted and right there yet to be assembled. In the final instrument, there's two photodiodes, one for each laser right in there, and two up in the top there. The two side ones, take half of the laser beam, which is split to as a reference beam, and then the other two photodiodes in the top detect backscattered light. In addition to lab tests, we've also flown this on a weather balloon just last month. You can see right here the instrument is mounted with the lasers pointed this way. The top 2/3 of this at least is just the balloon instrument.